Our next riddle, a pair of twins is how many people? Explain. A pair of twins is how many people? Explain. Alright, I'll get back to you. So just to fix my stupid mistake in the last video, like I didn't want to go back and I don't want to redo the whole video for that little mess. But solving for this value here, when you know x and x, when you have the two sides of a 45, 45, 90 right triangle, the two sides, two legs have the same measure. And then if you just use the Pythagorean theorem, x squared plus x squared equals, let's say it's y, let that length of the hypotenuse be y. Solving for y, you get 2x squared equals y squared, and finishing that up right up here, take the square root of both sides, you get the square root of 2 times x equals y, and I don't know what was going on in my head when I was doing that, but I apologize. And let's go ahead and turn the page and let's tackle this first example. Okay, so we're finding the volume of the solid shown in the figure, and it's really hard to see. Let me zoom in a little bit here. Okay, so we've got cross sections that are equilateral triangles, and the cross sections, as you can see, hopefully you can see this, are perpendicular. The base, at least, of the cross section is perpendicular to this being the x-axis coming right toward us. Okay, and so our main goal is to figure out, well, what's the length of that base right there, and that's what we're always going to really be trying to find. What is the length of the base? Okay, you can see a two-dimensional shape here. If you look straight down on top of the figure and look at the base of this three-dimensional solid, you can see that that line segment right there is the same line segment as that one right there. So like I said, it's a little harder to visualize, but hopefully you're not having too tough of a time to do that right now. The functions here, f of x is defined to be 1 minus x over 2, and down here the g of x is negative 1 plus x over 2, which you can see that. And so the distance between any 2 points along these curves would be the top curve minus the bottom curve, as we've done before. And so that radius, or I shouldn't say radius, I used to call it a radius, but it's just a distance now. It's the length of the base of this triangular cross section. And the cross sections, if you read closely here, look at this closely, you can see that the cross sections are equilateral triangles, and equilateral triangles, so all sides have the same length. So if we find the length of one side, we can find the length of all sides. So anyway, let's figure out what this is. This would be f of x, this length here of the base, minus g of x. And so let's go ahead and move this over. F of x is 1 minus x over 2. G of x is the negative 1 plus x over 2. Okay, and we get 1 minus x over 2 plus 1 minus x over 2. So what we have here is 2 minus 2 of these. 2 times x over 2, which is equal to 2 minus x. So that's a nice and convenient length of a base. So that's pretty nice there. Okay, well the hard work, part of the hard work is over, and what I like to do is, let's see, we have a lot more room down here, so let's do this down here. I want to take a look at the cross section's face. Okay, so now we're looking at the face of the cross section. Face of cross section. Trying to be aware of making sure that you can see what I'm writing. So the face of the cross section, this distance right here, that length right there is our 2 minus x. Remember, that's the base. Okay, and that means, well, what's the area of a, remember, all we need is the area of this face multiplied by dx, and we've got the volume of one cross section. So that's our goal. Okay, but we know that the area of a triangle is 1/2 base times height. So we need to figure out what that height is. This is where your geometry and algebraic skills are going to come into play. Okay, so if the length of this whole base is 2 minus x, then because this is an equilateral triangle, the length of, we're going to look at just this triangle right here, okay? The length of this from this point here to this point is half, okay? 2 minus x over 2. Alright, hopefully you can see that. That's 2 minus x over 2. Alright, but now we need to figure out what the height of this triangle is. And if you remember, an equilateral triangle also has all three angles. All three angles have the same measures. This is 60, that's 60, and that means that in this half of a triangle here, that's going to be your 30-degree angle. Okay, so we have our 30, 60, 90 right triangle, and we just talked about that. This leg right here, opposite the smallest angle, is going to be the shorter leg. Now the shorter leg, when you multiply the shorter leg by radical 3, you get the length of the longer leg. So the longer leg, which is the height of the triangle, which is what we need, is let's see, the easiest way to write this would be radical 3 times this whole thing, but I'm going to bring that 2 out there. I'm going to write it as 2 minus x. Okay, so we've got radical 3 over 2 multiplied by the quantity 2 minus x. That's the height. Okay, and so now we can find the area of the face. Area of the face. The area of the face is 1/2 times the base times the height. So we have 1/2, and the base again is 2 minus x over 2. 1/2 of the base. Sorry, I already did that. I already took that. So the base is 2 minus x. 1/2 of the base multiplied by the height, and the height is radical 3 over 2, and multiplied by 2 minus x. That's a big mess. Let's clean it up a little bit. And let's write it as radical 3 over 4. 2 times 2 is 4, and then we have our 2 minus x quantity squared. That's our bread and butter right there, guys. Right there. When you get the area of a face, you are virtually done. Okay? So that's what we need. You concentrate hard on that, making sure you get that right, because that's going to be your integrand. You're going to multiply that by dx to get the volume of one cross section, and then you're just going to integrate from left to right. Okay, so let's go back and finish this problem up. Okay, if you notice, this distance right here is what we found to be 2 minus x. Okay, this cross section here, we're going to integrate and add up an infinite number of cross-section volumes from the leftmost point to the rightmost point. Okay, the left boundary would be 0, and the right boundary would be 2. You can clearly see that. So 0 here is your lower limit of integration. 2 right there is your upper limit of integration. And we're good to go. Okay, so we have volume equals the integral from 0 to 2 of the, so this is total volume, okay, of our solid, and the volume of one cross section. I'm going to write all this in. I don't usually do this, but definitely in the very beginning we want to do this to make sure you're understanding that an integral adds up an infinite number of things. Those things in this case happen to be cross-section volumes. And so we just found the volume of our cross-section, which is an equilateral triangle face. And so we have the area of the face. And we're going to multiply that by the width of the face. This is the last time I'll be writing out all this stuff, so I know this is a little tedious, but I want to make sure that you're aware that all these problems are really this right here. From the beginning to the end of the interval, area of the face multiplied by the width. Okay, they're all the same thing. Okay, you're always going to do that. Find the volume of one cross section. We know that the area of the face is radical 3 over 4. We know, multiplied by 2 minus x quantity squared. Okay, and the width of the face is dx. Okay. And I'm not going to go through the process of showing you how to type that into the calculator. I'm just going to give you the answer, and the answer is 1.155. So that's what I got, and something tells me that that's not right, because it just seems like it's way too small to be the right answer. So I'm going to give extra credit to anybody that can show me why that's not right. I can't find a mistake. I think it's right, but it just doesn't look right. It just doesn't feel right. So anyway, that's how you do it, and we'll see you in the next. Oh, a pair of twins is how many people? That would be two. Speaking in the singular, a twin is one person. A pair of them are like a pair of shoes. One pair consists of two items. You probably already knew that anyway. You guys are so clever.